Hey guys, so today we're just going to start on trigonometry and just going to do a little bit of an introduction before our class. So just first of all, a reminder of how to find the length of the third side in a right-sided triangle when you know the length of the other two sides. And you remember that before Christmas we looked at Pythagoras' theorem, and that theorem said that c squared is equal to a squared plus b squared. So when we're looking at c squared is your hypotenuse, you'll remember that. And a squared is, so I suppose the better thing to say here is that c is your hypotenuse, not c squared. And then that your other two sides, a and b, can be either the opposite or the adjacent, it doesn't matter. So just as a bit of a recap, what I want you to do now is I want you to pause the video. I want you to have a go at finding x in this equation, or in this triangle here. So x, we can see, is the side opposite the right angle triangle, so we know that that's the hypotenuse, so that might help. And then in this question here you have two triangles, so you're going to have to start off by finding x and use the information from this triangle here. So these two sides, this is the number 13, and when you find x, then it'll help you find y. Now remember, you'll have the hypotenuse, you'll have one other side, and you're trying to find another side, so you'll have to do a little bit of manipulation there. So pause the video, and then when you're done, come back and we'll have a go. Okay, so using our formula then. So our formula is c squared is equal to a squared plus b squared. And my c squared in this case is x to be squared. My a, it can be 21 or 20, it doesn't matter. 21 squared plus 20 squared. And when I pop that into my calculator, I get 21 squared plus 20 squared gives me that x squared is equal to 841. And then you'll remember that what I have to do is to find x by itself, I need to square root both sides. So what I'll get is x is equal to, and the square root of 841 is 29. Okay, for the second question then, so first of all I'm going to have to work with this triangle here, and I'm going to use my formula. So my c squared again in this case is x squared is equal to 84 squared plus 13 squared. And that gives me that x squared is equal to, so 84 squared plus 13 squared is equal to 7225. And again, I'll have to square root both sides to get x by itself. And when I square root that, it's equal to 85. So x is 85. And now for my second triangle, what I have here, so my hypotenuse in this case you can see is 85, because that's the side that's opposite the right angle. And then one of my sides is 36. So what I get is I get 85 to be squared is equal to 36 squared plus y squared. And if I want to find out then what y squared is, I am going to just bring this whole thing over the far side. So I get 85 squared minus 36 squared is equal to y squared. Now I'm just going to skip a step here, just because you should be used to what we're doing here now. So I have y squared is going to be equal to, so y squared is equal to 85 squared minus 36 squared, which will give me 5929. So then my y, when I root both sides, square root 5929, is going to be 77. Okay, so looking at trigonometry then, what is it? So trigonometry allows us to find out one of two things. So the size of the other angles in a 90-degree triangle when you know the length of the sides, and the length of a side given one other side and an angle, or vice versa. Okay, and what you need to know here is these formulas are on page 16 of the log tables. So if you remember, a right angle triangle looks something like this, and this is my right angle. So this is what we call the hypotenuse. If we are looking at angle A here, then our opposite is going to be this side. If we are looking, and then the adjacent is going to be this side. So if I have the same triangle, I'm just going to duplicate that and just move it over here. If I have the same triangle and I'm now going to look at angle B, so this angle in the corner, in the opposite corner. So let's say I'm looking at B. Now that changes our perspective, because the side that is across from that is now the opposite. So now this is the opposite side, and this is the adjacent. So the adjacent, it's really important to know here that the adjacent, ADJ, we often kind of refer that to, it runs alongside the angle. And the opposite is opposite the angle, okay? And we can see that here. So B, this side is opposite. Here in A, this side is opposite, even though they're the exact same triangle. And it's just because of whatever side or whatever angle that we're going to be looking at. Okay, so we're going to look at some trigonometric ratios here. So we can see the angle A, and we are going to just apply the ratios that we had in the last slide. And again, they're on page 16 of your formula tables. So the sine of an angle A is going to be the opposite over hypotenuse. And in this case, the opposite to angle A is 21 and the hypotenuse is 29. So what I get there is 21 over 29. So that's a trigonometric ratio. The second one, so cos, so that's adjacent over hypotenuse. And when we look at this, it's adjacent is this side here, so the side that runs alongside the angle, and that's going to be over the hypotenuse. So I have 20 over 29. And the final part, tan of A. So tan is adjacent over opposite. Again, these formulas are in your log table. So we have adjacent over opposite. So adjacent to this is 20 and the opposite is 21. So I have 20 over 21. Okay, what I want you to do now is I want you to look at angle B. I want you to pause the video here and have a go at writing the sine B, cos B. So sine B, cos B, and tan B for me now. And when you have that done, just press play in the video and then we'll continue. Okay, so let's have a go at that. So sine B, we know from over here, is opposite over hypotenuse. So my opposite side to B is the side of 20 and it's over my hypotenuse, which is 29. Then we have the cos of B, so cos being adjacent over hypotenuse. So adjacent to B is the side 21, and that's going to be over the hypotenuse, which is also 29. And tan of B then is going to be the adjacent, which is 21, over the opposite, which is 20. Okay, so just to work through one more example here. So you'll notice that these two examples are the ones that we had earlier for Pythagoras theorem. So when we're looking at this, I'm just going to start off with the B first. And again, get you to pause it. If you want to pause it now and try it yourself, that's fine. So we have sine of B. So sine is opposite over hypotenuse. So our opposite is going to be 77 and my hypotenuse is 85. So that's 77 over 85. And just for the moment, I'm not going to worry about simplifying these trigonometric ratios. So cos of B then, so cos is adjacent over hypotenuse. So adjacent is the side 36 because it runs alongside the angle B. and the hypotenuse is 85. And the final part, tan of B. So tan is adjacent, which is 36, and that's over opposite, which we can see is 77. So have a go now at writing the sine of C, the cos of C, and the tan of C for me now. When you're done, press play and we'll continue. Okay, so let's look. So sine of the angles. Let's just look at it all at what where our angle is and what's where. So our opposite's going to be 36 because that's the side that's opposite to it. And then we have our adjacent, which is 77, and our hypotenuse doesn't change. So we have opposite 36 over hypotenuse, which is 85. We have cos is the adjacent, which is 77 over 85. And then finally, we have tan of adjacent 77, which is over the opposite, which is 36.